Hey, Compact students, this is Miss Moyer with 16.7, Operations and Scientific Notation. This is part 1, multiplying and dividing. Your notes are in the order of addition and subtraction first, so you just have to skip down to where it starts with the multiplication and division. Okay, so in example 2, you will see we are having this problem. 3 times 10 to the negative fifth is one number, multiplied by 5 times 10 to the negative second. And we're asked to write our answer in scientific notation. So what we need to do is think back to some of our rules of mathematics. So we know that in addition, order doesn't matter. So we know 2 times 3 is the same as 3 times 2. We also know that if you've got only multiplication and parentheses, the parentheses don't matter. So for example, if we have 2 times 3 times 4, with the parentheses around the 3 times 4, it will give you the same answer if you do it that way or if you put the parentheses around here. So essentially two things. Order doesn't matter in multiplication. That's the commutative property. And parentheses don't matter when it's only multiplication. That's the associative property. So here we've got in our question all these things multiplied together. Notice it's all multiplication. So since every operation is multiplication, we don't need those parentheses. Okay, so we don't need the parentheses, and we have some numbers that are going to be easier to combine than others in multiplication. We know some exponent rules that are going to help us combine those powers of 10. So I'm going to rewrite our expression so that our factors of 3 and 5 go first, and then our powers of 10 go next. And we'll work on each group here as its own thing. So 3 times 5 is 15. And 10 to the negative fifth times 10 to the negative second, it's multiplication. So we add those exponents. So it becomes 10 to the negative 5 plus negative 2, or 10 to the negative 7. And sometimes in these problems, that's it, you're done. But if you're looking at this, you may notice this number is not in scientific notation yet, because our factor is bigger than 10. So there's a lot of different ways people fix this. I think the most reliable way is to take a minute and write this number in scientific notation. So to write a number in scientific notation, you take the digits and put a decimal after the first place. Then you multiply it by a power of 10. That puts the decimal place back where it's supposed to be. So I'd have to multiply it by 10 to the first. So to finalize our answer, we have to combine these powers of 10. So our final answer becomes 1.5 times 10 to the negative sixth, because again, we're adding those exponents because it's multiplication. 1 plus negative 7 is negative 6. And to sort of help you see that this really is true, I have converted both of our numbers into standard form. So we've got 0.00003 times 0.05. 3 times 5, when we start doing this multiplication out, we get 15, and then we have to figure out how many decimal places go in. So we've got 1, 2, 3, 4, 5, 6, 7. So we've got 1, 2, 3, 4, 5, 6, 7. So our final answer would look like this, 0.0000015, or 1.5 times 10 to the negative 6. So I've got to move the decimal from here in my factor form all the way back there. So it works out. We get the same answer. And just to note, sometimes the factors aren't just 3 and 5. Sometimes these would be really difficult to multiply together, putting them in standard form. It is really a good skill to understand how to do this without taking them out of scientific notation. Okay, here are 2 problems for you to practice. 3 is a little more straightforward, should be pretty quick. 4 is a little bit more complicated, but not tons. Give those a try, pause the video, and come back when you're ready to check your answers. Here are the answers. Take a look through at the steps. Pause the video if you want to take a look a little closer. Okay, so the math background we need to remember for the dividing in scientific notation is really about fractions. Dividing numbers in scientific notation is much, much, much easier in fraction form than it is with the old-fashioned division sign like that. So we're really going to say, anytime you see a division problem with this in it, get rid of it, make it a fraction. So let's take a look at some fraction ideas here that we need to take a look at. So if we had 2 over 3 times 5 over 7, remember that the way we do that is we multiply straight across. So if these two things are the same, right, we usually are going this way, but sometimes we need to split up a big crazy fraction. So sometimes we go that way, and that's the idea that we're going to start with here. So we've got 1.5 times 10 to the negative 8th divided by 6 times 10 to the 7th. And we know what to do with that fraction. We also know what to do with that fraction. So we're going to split this big fraction apart into 2 things. So we're going to say that all of this is the same as 1.5 over 6 times 10 to the negative 8th over 10 to the 7th, just like what we were talking about up at the top. So we're going to deal with each fraction individually. So to simplify the 1.5 over 6, remember what we're looking for. We're in scientific notation. We need this to be in decimal form. So we could do 1.5 divided by 6, or we could take that 1.5 over 6 and try and turn it into a simpler fraction. Either way, it doesn't really matter. I noticed that if I multiply this by, not that, 2 over 2, we get 3 over 12, which reduces to 1/4, and I know that one. That's 0.25. So I could choose that method, or I could do this division over in the middle. 6 goes into 1 0 times. 6 goes into 15 twice. With 3 left over, 6 goes into 35 times. Either way, I see that that fraction is the same as 0.25. And then we have to simplify our exponents. So when we have division of exponents, we subtract. So 10 to the negative 8th divided by 10 to the 7th, we are going to subtract and get 10 to the negative 15th. This is a really small number, really, really small. And when you think about it, we have in the original problem, we have a really, really small number being divided by a really big number. And so this big number is not going to fit into a small number even one time. It's going to fit in just a teeny fraction of a time. And that's what our answer is going to give us. So our answer, we're really close, but it's not yet in scientific notation. So we have to do a little more work. So we're going to take our factor and rewrite it in scientific notation. So that would be 2.5 times 10. And we think about, to go back to where it should be, we have to move left 1. So that's a negative 1. So it's 2.5 times 10 to the negative first times that 10 to the negative 15th. So our final answer, we combine these powers of 10 by adding their exponents, 2.5 times 10 to the negative 16th. Okay, here's some on your own practice of division. Pay attention. The dreaded division symbol is here. Remember what to do. Make it a fraction. So pause the video, give it a try, and unpause when you're ready to see the answers. Okay, so here are your final answers. In number 5, It turns out to be relatively straightforward because 9.2 divided by 4.6 is just 2. So there's no conversion needed here because we end up with our answer already in scientific notation. I did put in a little times 10 to the 0th. You really don't need it here, but sometimes I know kids get mixed up when there's nothing to divide that 10 to the 12th by from the numerator. It just messes them up. So remember 10 to the 12th over 10 to the 0, 12 minus 0 is still 12. So sometimes putting that there helps people see what's happening. You really don't need it. On the right, I wanted to just point out when I had 1.5 over 7.5, I multiplied both of those by 10 when I went from the first step to the second. I knew to reduce that to 1/5, and I knew that 1/5 is 0.2. So that's sort of that progression. This one you did have to convert to scientific notation since 0.2 is less than 1. This is not in scientific notation. So you had to convert that over to scientific notation here. Okay, your assignment to practice this is from the textbook, page 752, numbers 17 through 23 odd. Remember, those odd answers are always in the back of the book, so if you're in the online textbook at bigideasmath.com, at the top left of that homework assignment, when you're on regular Zoom, there's a little check mark button. You can click that and get the final answer so you can check your work. Have a great rest of your day, and I will see you tomorrow with the part 2 video.